Today, doesn't that hard shell we see on the heads of millions of motorcycle riders, including myself, remind you of a turtle? Or perhaps one of the most important safety inventions in human history? Have you ever wondered why people didn't wear helmets when the first motorcycles were built? Or couldn't they find a coconut the size of their heads? Who knows? This technology, which now saves the lives of MotoGP riders traveling over 300 kilometers per hour, was actually born after a single fatal accident. And the interesting part is, the man who laid the foundation for the modern motorcycle helmet wasn't an engineer or a motorcycle manufacturer. He was simply a brain surgeon trying to save lives. So, how could a doctor become the pioneer of the world's first modern motorcycle helmet? To answer that question, we have to travel back thousands of years. Throughout history, humans have always searched for ways to protect their heads. On ancient battlefields, the deadliest blows almost always landed there. Around 3,500 years ago, the Sumerians and Akkadians living in Mesopotamia began wearing heavy bronze helmets. Later came the famous Corinthian helmets of ancient Greece, covering almost the entire face. During the Roman Empire, iron and steel helmets appeared as metallurgy advanced. These helmets could stop arrows, swords, and even spears. But they all shared one thing in common. None of them were designed for traffic accidents because motorcycles didn't even exist yet. Everything changed in 1885. German engineers Gottlieb Daimler and Wilhelm Maybach developed one of history's first gasoline-powered motorcycles, the Reitwagen. It was small, practical, and revolutionary. But there was one major problem. Nobody thought they needed protection while riding it. People simply wore their everyday clothes, thick leather jackets, leather gloves, and sometimes nothing more than a simple hat. Looking stylish seemed far more important than protecting your head. Speeds were still relatively low, but crashes were unavoidable. No one imagined that only a few decades later, motorcycles would exceed 150 kilometers per hour. By the early 1900s, motorcycle technology had advanced dramatically. Engines became more powerful, races were organized, and new manufacturers appeared almost every year. But while motorcycles became faster, safety barely changed. Riders who crashed almost always struck their heads first. Serious injuries became common, and newspapers published more motorcycle deaths every year. Yet people still refused to believe that helmets were the answer, because at that time, one dangerous belief dominated society. If you fall, you won't survive anyway. That belief remained unchanged for years, until one accident changed everything. On May 13, 1935, in Dorset, England, the world-famous soldier and writer Thomas Edward Lawrence, better known as Lawrence of Arabia, was riding his beloved Bro Superior motorcycle. Within seconds, everything would change. Two children suddenly appeared on bicycles directly in his path. Lawrence made a sharp maneuver to avoid hitting them, lost control, and was thrown from the motorcycle. His head struck the ground with tremendous force. He wasn't wearing a helmet. For 6 days, Lawrence fought for his life. Despite every effort, he died from severe head injuries. At first, it seemed like another tragic motorcycle accident, but history would remember it as the event that transformed motorcycle safety forever. His death caught the attention of British neurosurgeon Dr. Hugh Cairns. Instead of accepting the accident as unavoidable, Cairns began asking a different question. Could this death have been prevented? For years, Dr. Cairns carefully studied motorcycle crashes involving both soldiers and civilians. Again and again, he reached the same conclusion. Most victims didn't die because of broken bones, they died because of catastrophic head injuries. His findings were impossible to ignore. Cairns prepared scientific reports, presented them to military leaders, and urged the British government to require protective helmets for military motorcyclists. His campaign would eventually save thousands of lives. During World War II, the British Army widely introduced protective motorcycle helmets for dispatch riders and military personnel. Fatal head injuries dropped dramatically. For the first time, helmets had proven they could truly save lives. By the late 1930s, several manufacturers had already begun producing the first hard-shell motorcycle helmets. Compared to today's designs, they were incredibly simple, but they marked the beginning of a completely new era. Their outer shells were made from compressed fibers, hardened leather, or resin-reinforced materials. Inside, there was almost no impact-absorbing foam. They couldn't eliminate injuries, but they greatly reduced direct blows to the skull. For the first time in history, riders were deliberately protecting their heads before starting a journey. It was a simple idea, yet it would evolve into one of the greatest life-saving inventions ever created. And the biggest revolution was still to come. In the 1950s, motorcycle and automobile racing exploded in popularity across America. But as speeds increased, so did the number of fatal crashes. Racing drivers needed something stronger, lighter, and far more reliable than anything that existed before. That was the moment Bell Helmets entered the scene. The company focused on building helmets specifically for racers, not just harder helmets, but smarter ones. Helmets that could absorb energy instead of simply resisting impact. Bell engineers introduced one revolutionary idea: a rigid outer shell combined with an energy-absorbing inner liner. Instead of transferring the force directly to the skull, the helmet spread and absorbed much of the impact. That principle is still used today. By the end of the 1960s, the motorcycle industry had accepted an important truth. A helmet was no longer just an accessory. It had become essential safety equipment capable of saving a rider's life in a fraction of a second. Manufacturers no longer focused only on making helmets stronger. They began designing shells that absorbed impact, stabilized the head, protected the jaw, and improved the rider's field of vision. A new generation of helmet was about to arrive. Then came 1968. Bell introduced a helmet that would forever change motorcycle history, the Bell Star. It became one of the first successful full-face helmets to reach mass production, and it completely changed how riders thought about safety. At first, many riders hated it. "It covers my face, I can't breathe, my vision is worse." But the crash statistics told a completely different story. Riders wearing full-face helmets suffered far fewer facial injuries. The racing world quickly embraced the new design. Soon after, everyday riders followed. Today, nearly every modern full-face motorcycle helmet can trace its design back to that revolutionary Bell Star introduced more than half a century ago. But protecting the head wasn't the only challenge. Riders constantly faced flying stones, dust, heavy rain, and insects striking their faces at high speed. Even a tiny pebble could cause a serious accident if it hit the eyes. At first, riders relied on separate goggles. They fogged up, leaked air around the edges, and offered limited protection. Engineers realized that true eye protection had to become part of the helmet itself. And that's exactly where the next revolution began. Manufacturers decided to integrate eye protection directly into the helmet. The first built-in visors were made from transparent cellulose-based materials. It was an innovative idea, but far from perfect. Those early visors scratched easily, turned yellow after long exposure to sunlight, and could crack under heavy impact. They protected the rider better than goggles, but engineers knew they needed something much stronger. The next step was acrylic. It offered better clarity and improved durability. But the real breakthrough came with a material that would completely transform motorcycle helmets: polycarbonate. Polycarbonate was lighter than glass, remarkably clear, and dozens of times more resistant to impact. Suddenly, riders could enjoy better visibility without sacrificing protection. It quickly became the new industry standard. Modern premium helmets now use optical-grade polycarbonate or advanced composite visors. Many include anti-scratch coatings, UV protection, and anti-fog technology. Some even feature tear-off systems designed specifically for professional racing. But visibility wasn't only about the visor. Early full-face helmets had very small eye openings. Riders often had to turn their entire heads just to see through a corner, making high-speed riding both difficult and dangerous. Helmet designers spent years studying human vision. They reshaped shells, widened visor openings, and improved peripheral visibility. Every millimeter mattered, when a rider had only fractions of a second to react. Today's racing helmets provide a much wider field of view than their early predecessors. This allows MotoGP riders to spot the exit of a corner, monitor nearby competitors, and react instantly, even while leaning dramatically at extreme speeds. As helmets became safer, another problem remained: weight. Some of the earliest hard-shell helmets weighed nearly 2 kilograms. Long rides often caused severe neck fatigue, especially during racing. Manufacturers began searching for materials that were both lighter and stronger. Their first major breakthrough came with fiberglass. It distributed impact far more effectively than metal while reducing overall weight. Fiberglass was only the beginning. Engineers soon introduced Kevlar, a material originally developed for bulletproof vests. It was incredibly strong, highly resistant to tearing, and far lighter than traditional materials. The only downside, it was expensive. During the 1970s and 1980s, Japanese manufacturers transformed the motorcycle industry, raising the bar for quality and innovation. Brands like Arai and Shuei didn't just focus on building stronger helmets. They improved aerodynamics, reduced wind noise, enhanced ventilation, refined balance, and increased long-distance comfort. Through extensive wind tunnel testing, they made helmets remarkably stable at high speeds. This significantly reduced the physical strain on the rider's neck. Today, Arai and Shuei remain among the most respected helmet manufacturers in the world. A modern helmet is no longer judged simply by how hard it is, but by how effectively it manages impact energy. When you hold one in your hands, you're holding decades of engineering, thousands of laboratory tests, real-world crash data, and lessons learned through countless lives. Then, during the 1990s, another breakthrough arrived: carbon fiber. It combined extraordinary strength with exceptional lightness. Riders could finally wear helmets that were both stronger and noticeably more comfortable. Then, during the 1990s, another breakthrough arrived: carbon fiber. It combined extraordinary strength with exceptional lightness. Riders could finally wear helmets that were both stronger and noticeably more comfortable. Today, many MotoGP and Formula One helmets are built from carbon fiber or carbon aramid composites. These advanced materials spread impact forces across the shell, helping reduce the energy that reaches the rider's head. But here's something that surprises many people. The outer shell isn't the part that saves your life. Its job is to spread the force of an impact over a wider area. The real hero is hidden inside the helmet. Inside almost every modern helmet is a layer of EPS foam, expanded polystyrene. During a crash, this foam crushes under pressure. As it collapses, it absorbs a huge amount of impact energy before it can reach the brain. That's why experts always recommend replacing a helmet after a serious crash. Even if the shell looks perfectly fine, the crushed EPS foam cannot return to its original shape. Once it's damaged, its protective ability is permanently reduced. Modern engineers discovered another hidden danger. Not every brain injury comes from a direct impact. Sometimes, the greatest damage is caused when the head suddenly twists during a crash. To reduce these rotational forces, manufacturers developed new technologies such as MIPS, a low-friction inner layer that allows the helmet to move slightly during an angled impact. That small movement can significantly reduce stress on the brain. Today's best helmets don't simply try to resist impact. They carefully manage energy, control rotation, improve stability, and protect the rider from multiple types of collision. Modern helmet design has become a science. What began as a simple leather head covering has evolved into one of the most advanced pieces of safety equipment ever created. But before any helmet reaches a rider, it must survive some of the toughest safety tests in the world. Before a motorcycle helmet ever reaches a store shelf, it enters a laboratory. There, it faces impacts far more violent than most riders will ever experience. Every major manufacturer knows one thing: a helmet must prove it can save a life before anyone is allowed to wear it. Around the world, helmets must pass strict certification standards. In Europe, it's ECE 2206. In the United States, DOT certification is the legal minimum. Professional racing organizations rely on even tougher standards, like SNEL, FIM, and FIA. The first challenge is the impact test. A helmet is mounted onto an instrumented head form, then dropped onto different steel anvils from carefully calculated heights. Powerful sensors measure exactly how much force reaches the head inside. But not every crash happens on a flat road. Some impacts strike sharp edges, curbs, or uneven surfaces. That's why helmets are tested against several different anvil shapes, each designed to simulate a real-world accident. Modern standards also include angled impact testing. During these tests, the helmet strikes the surface at an angle, causing the head to rotate violently. The visor is tested as well. High-speed steel balls are fired directly toward the rider's eye area. The visor must resist cracking, prevent dangerous fragments, and maintain clear vision after the impact. Extreme temperatures create another challenge. Helmets are exposed to freezing cold, intense heat, humidity, and ultraviolet light. After enduring these harsh conditions, they must still pass every impact test all over again. Only after surviving every one of these demanding tests can a helmet earn its certification. That small label hidden inside your helmet represents years of engineering, thousands of laboratory impacts, and an uncompromising commitment to protecting human life. The next time you fasten your helmet, remember this: you're not wearing just plastic, foam, and carbon fiber. You're wearing more than a century of engineering, countless scientific discoveries, and lessons written in blood. Because sometimes the most important invention in your life is the one you hope you'll never have to test. And yes, now you know exactly how it was invented.